Hello, today is part 2 of wiring diagrams. We're going to be talking about relays and transistors. If you haven't seen part 1 of our wiring diagram video, go back and watch that, talking about all the different symbols that we use for wiring diagrams. Very standard symbols, very important to understand. So today is relays and transistors. Relays are for taking a low current circuit, like a transistor or an ECU, inside an ECU, and controlling a high current circuit, like a motor or a large solenoid, whatever you need it to do. Transistors are solid state. They're inside of ECUs, inside a body ECU, inside of an engine ECU, and we use them to switch very fast, but they can't take a lot of current. Relays cannot switch very fast, but they can take a lot more current than a transistor can. I've drawn some example wiring diagrams of how transistors and relays are going to work together. There's 2 types of transistors and 2 types of relays generally. You have PNP and NPN for transistors. PNP, power to power, and then has to be controlled by negative, which we're going to talk about in our diagrams. NPN is the opposite, ground to ground, controlled by a power supply. Basically what's going to happen is, you can see on our first diagram here, it's got a ground circuit coming through, and it's going to pulse power on there to actuate that transistor. When power is applied here, the circuit's complete. The opposites apply for a PNP. They ground that transistor to complete the circuit through the transistor. So, transistors aren't usually seen on a wiring diagram. You have to kind of interpret them. You'll just see on a wiring diagram it goes into a magic box, and you just have to assume the inside. So that's what we're talking about today. Here we have kind of a basic fuel pump circuit, 2 ways to do it, whether it's a high side driver or a low side driver. Low side's more efficient. They tend to last longer. So we have a fuse powering both sides of the relay, and the transistor is going to control the ground side of the control of the relay. The CPU in the transistor, when the conditions are right, according to the engine ECU, is going to power the transistor, completing the circuit of the transistor to ground, therefore energizing the coil in the relay. And it's a magnetic switch, and it pulls this lever over, completing this circuit, applying power to the fuel pump. Fuel pump just has a direct ground to it, and that's it. In this circuit, the transistor is a high side driver, so it controls the power side of this relay. So we have a fuse sending power directly into the transistor. This transistor is going to get controlled on the ground, so when the transistor gets grounded by the engine ECU, power is going to flow through the transistor, go through the coil, and to ground. The coil is going to be energized, hold the switch over on the relay. Power from the relay fuse is going to go through the relay, powering the motor, running our motor. And in this case, it's going to be a fuel pump. That can be a headlight, it can be whatever light, it doesn't matter. The whole point of relays is low current circuit controls a higher current circuit. So the other purpose of transistors, why can't we use a transistor to control these fuel pumps directly? Why don't they just make them bigger and get rid of relays altogether? They'd just be too expensive, or the technology is just not there to do it. Another cool thing they can do is transistors switch really fast because there's no moving parts. Relays, when you switch them, you can hear them click. So here I've taken a cutout of an injector circuit for a 4-cylinder. Here's a circuit on how injectors work with transistors. Ignition switch is going to close, and the relay is going to get energized and close, and it's going to apply power to the 4 injectors. Now, the engine ECU is going to want to control each injector, how long it stays open, and when it powers them on individually. So the CPU is going to go and ground the injector to open the injector. It's going to apply power to the transistors, completing the circuit to an internal ground within the ECU, firing the injectors in the firing order, holding them open for whatever amount of time, depending on engine load, engine speed, whatever. In the next video, we're going to talk about more things that transistors do, like pulse width modulation, duty cycle, and really the cool things that they are used for on a vehicle, like dimming light bulbs, and varying the speed of a motor, ways like that, and how we diagnose that with a meter, and how that's going to look on an oscilloscope, stuff like that. So join me in the next video, and we're going to learn about that together. Thanks for watching.